Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that. It'll open a new box. You can type in your question, hit submit, and I'll get to those at the end of the session. If you're watching us on YouTube, just use the live chat function wherever it happens to be on your screen. You can go in there and leave me a chat, and we'll get to those comments and questions at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced to help everyone get the most out of their diagnostic needs. And before that, it was 8 years at Subaru. So worked at a Subaru dealership, and over time, I guess, became that diagnostic guy in the shop. So always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type problems that would come into my bag. And before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is forced induction. Forced induction overview and diagnosis. So if you just heard, I used to work at Subaru, and boy, we had a lot of forced induction issues would come into the shop. So this is kind of a little sweet spot near and dear to my heart. I guess you could say near and dear to my heart. Definitely had quite a fair number of experience with it anyways out in the shop. And maybe you've seen turbo vehicles or supercharged vehicles, because we're covering both here. Maybe you haven't yet, but I'll tell you what, it has really taken off in the last few years and over the last decade or so for sure, as to how many vehicles out there on the road actually have a turbocharged vehicle, let alone even supercharged vehicles, which is the other half of the equation. Starting back in 2000, it was just maybe 1 or 2%. All the way up to now, it's over a third of vehicles on the road, or a third of the vehicles that are out there manufactured anyways, are turbocharged and then supercharged as well. And you think about pickups and SUVs and such, diesel vehicles, they all have turbochargers, right? And then of course the cars do as well. And then not so many in the vans. That's a very small little line right there on the vans, but I guess it's probably not a ton of turbocharged vans out there. But definitely your pickup class and your car class for sure have turbochargers, superchargers, that sort of thing. I looked up through ShopKey every manufacturer that we cover in 2020 model year. I decided to go back a couple years. But every manufacturer that is covered in 2020 model year in there, every single one of them have a turbocharged engine available at some point on some model. So every single one of these manufacturers on this screen is going to have a turbocharged, some sort of forced induction engine, but it's mainly turbocharged nowadays. Superchargers were a little bit more common back, maybe 10, 15 years ago, but turbochargers really come on as the forced induction mode of choice out there on the vehicle. So why do we use forced induction anyways? A lot of it has to do with creating more power out of a smaller engine package. I can do a 2-liter, 1.6 liter, 1.8 liter, put a turbo on it and still get a couple 300 horsepower out of it. Well, that's pretty good. If I do turbo combined with, say, direct injection, that can be very, very economical fuel-wise. Plus, if I have a smaller engine displacement, 4 cylinders instead of 8 cylinders, and I can still get similar power, then why would I not do that as a manufacturer? It saves on a lot of raw materials as well. Plus, we can run them a little bit more lean. We don't want to run them too lean, but especially like in the diesel world, we can run them more lean, which also gives us better miles per gallon because we're cramming more air into there versus the amount of fuel that we would need in order to do that as well. So that's really why a lot of manufacturers have gone to this forced induction idea, because, well, if I can get more power out of a smaller displacement, that's definitely a good way to go keep that miles per gallon down, or the fuel economy up, as we would think about it. So there's many different components. Some of them are shared between, if it's a supercharger or a turbocharger, they will share some of the same components in the system. But we will talk about the supercharger and the turbocharger. We'll also talk, when we're talking turbochargers, variable geometry turbos. So that has an actuator involved with it. So we'll talk about that a little bit. the wastegate, boost control, blow-off valve or recirculation valve, whichever way we have it. And then, of course, the intercooler in there as well. We'll talk about all these different components, kind of how they work, that sort of thing as we go through this class. So first off is the supercharger. As I said, this is not as common. I think overall it's really not as common as turbochargers are, but they are out there. And I think they've kind of fallen by the wayside at this point. There may be a couple models out there that still have it, but by and large, pretty sure most manufacturers have gone that full turbo route. Whether it is a supercharger or a turbocharger, it is an air compressor. If it's a supercharger, it is a belt-driven air compressor, so it runs off the engine. There are different types out there. There's a screw type, a scroll type, and a centrifugal type. We're going to talk about the differences between those. And it does use the engine power to drive it. So in that case, because of that, we have a bit of a parasitic drag on the engine as well. So it can reduce the power output less than what it could have if it was not driving the supercharger. Of course, the boost will increase the power output of the engine, but we lose a little bit of that because of the power of the engine used to drive the belt on the supercharger. So here's a roots type supercharger. So that'd be that screw type supercharger I'm talking about. Has two screws intermeshed with each other. And what that does is it takes the air from a large volume and compresses it down to a smaller volume. And that's what allows us to create more pressure. So as we can see, the air flowing around the screws and getting squished down to increase the amount of pressure in the air, which increases the density of the air. There's also a scroll type supercharger. So it looks kind of like this. Internally, it's got some grooves in there. And as it spins, the air comes in and then it goes around and it gets pressed smaller and smaller and smaller and smaller as it goes through into the output stage, which is in the middle. So the input's on the outside, the output's on the inside. And then as it goes around the circle and gets forced around the circle, it slowly gets compressed, fills a smaller space, and that's what gives us the boost. That's what gives us the higher pressure going through there. We also have a centrifugal supercharger. You may have seen these. Some aftermarket companies make these as well, just kind of a bolt-on type of thing for a vehicle. And when I think of centrifugal supercharger, it's kind of like I think a half turbo, half supercharger hybrid is what it works out to be. The drive side of the compressor is going to be driven by a pulley, much just like any other supercharger out there. Then we have some reduction gears in there, some bearings, and then we have the impeller on the compressor side, which pretty much looks like a turbocharger, as we'll see in a little bit when we actually talk about turbochargers, but it does the same type of thing. Air goes in, goes through a large volume, gets compressed into a smaller volume, which gives us an increased pressure, increased boost pressure to the engine. All right, so we have all of that. So that's kind of the three different ways they do it. One of the more common ones is going to be that screw type, roots type supercharger. If you've ever seen like a funny car, a top fuel dragster, that's usually a screw type, roots type blower on the top of that, except it's got a massive belt and massive screws, and it's just pounding in the boost into that engine there. But it's the same type of idea. It takes that air in, compresses it, and then the compressed air goes out. So what can we have for problems with superchargers? This is a story that we've been telling this story for a very long time, but I thought it was a very interesting thought process when it comes to a supercharger and how we can have a failure with a supercharger. So the customer complaint is lack of power, engine lights on, and got a little bit of a noise in the front end as well. So they think, okay, well, maybe it's a supercharger problem. So they go in, of course, you want to scan it for codes. First thing we want to do. So they go in, code scan, and they come up with this P1688 code. So electronic throttle control motor level 2.3, mass airflow calculation. So just thinking about the definition of this code. Where could the problem be? Well, it could be in throttle, I suppose. Throttle control monitor, right? Mass airflow calculation. So maybe it's a mass airflow sensor. Maybe you might think it could be a problem with the ducting. Or maybe it could be a supercharger, I suppose, too, right? Not moving the amount of air that it's supposed to. So we'll go and hit diagnose and go into the intelligent diagnostics, fast track intelligent diagnostics. And we see right off the bat, there are two TSBs related to this problem. So let's take a look and see. We'll go on this first one here, DME fault P1688. So DME is BMW Mini's acronym for their engine control computer. And digital motor electronics, what it stands for. And this is for the vehicles with the W11 engine. So the W11 engine on the Cooper S is going to be the supercharged version of that engine. So let's see. Customer complains of lack of power. Engine is in fail-safe mode. Service engine soon light is illuminated. And fault code P1688 is stored in the DME. So let's see. Customers complaining of lack of power. This customer is. Engine in fail-safe mode, service engine soon lights on, P1688. Sounds like that could be our ticket. Let's see. This fault can be caused by one of the following. Possible air leak in the induction system. That's a good thought. Map sensors are indicating implausible values. Okay, it could be a sensor. Failure of the supercharger bypass valve sticking operation. Okay, so we'll talk a little bit more about bypass or recirculation valves, but that is that's a possibility too. So we go down a little bit further, gives us the procedure to do. So check the complete air intake system, including throttle body, supercharger, intercooler, and inlet manifold for air leaks, because that could be a problem. We could have an air leak somewhere, metered air getting out. If no problem is found, verify both the manifold pressure sensors show plausible values. If they're not plausible, refer to the sensor test module for that. So if it's not plausible, yeah, maybe I have a bad sensor. If the values are plausible, replace the supercharger bypass valve. There's the part number. And reprogram the computer. So in this case, they say, all right, so it's got to be that valve. If everything else is okay, go for the valve. All right. Good plan, maybe. Let's see. We'll go a little bit further. We'll go to the other one. W11 engine again. Diagnostic hints, lack of power, engine fail-safe mode, engine light on, P1688. Possible failure of that bypass valve again. Say it could be a problem with that bypass. This is interesting, though, down here. So when performing the guided test here in test module after fault P1688 is stored, in most cases, the test plan incorrectly directs the technician into replacement of the DME control module. So this says it incorrectly tells you to replace the computer as we go through it. When diagnosing it with this fault, inspect the proper operation of the bypass valve in the air intake system. Using a handheld vacuum pump, activate the bypass valve and observe its operation. If sticking in any position, replace it with a new part. There's the part number there. Okay, so both TSBs in this case refer to replacing that valve. Also, it refers to it could be a control module. Also refers to it could be a problem in the air intake. So that's our TSBs. Let's go over here though. This is where it got interesting when we were looking through this. Overwhelmingly so. Looks like peak at around 100,000 miles too. Overwhelmingly so. The repair, top repair for this particular problem was replace the harmonic balancer 188 times over 200,000 miles. Most occurrences is 65 at 100,000 miles. Next thing on the repair order is the crankshaft bolt. That makes sense because that's probably going to go with the balancer. Belt tensioner, probably going to do that at the same time. Replace the supercharger 11 times, and then the fuel filter 1 time, maybe for a lack of power. Maybe they thought it was clogged, or maybe they just did it as a matter of course with the rest of the stuff. But replaced harmonic balancer. That's odd. You would think on a mass airflow calculation that sounds a little weird, but the plot thickens if we go down a little bit further and look at the number one real fix for this problem. Customer states check engine lights on, vehicle lacks power on acceleration. Confirmed the customer's complaint and found the vehicle lacked power on acceleration, connected a scan tool, found P1688 in there. At idle, back probe the mass airflow sensor and monitor the sensor signal on a lab scope. That's a good plan. Mass airflow sensor signal observed on the scope was within specification. So that means I tested the mass airflow sensor and it's fine. Performed a second road test on the vehicle and heard a slight metallic noise from the front of the vehicle that time and smelled a burning rubber odor. So that's never good. Hoisted the vehicle, inspected the front of the vehicle, and noticed the crankshaft pulley had separated from the harmonic balancer. The crankshaft pulley is integrated in the harmonic balancer and is replaced as an entire unit. The damaged crankshaft pulley caused the digital electronics module, or DME, to miscalculate the vehicle's engine speed. Therefore, the DME miscalculated the engine load parameter and set the trouble code. So long story short, harmonic balancer on this engine. It's got the pulley on the outside. What is that pulley driving? It's driving the supercharger. If it gets separated because it's just rubber in there, if the rubber breaks down and it separates, the engine is spinning at one speed, the pulley is spinning at a different speed, the supercharger is not spinning at the right speed. It's metering air, it's metering loads, it's checking RPMs versus what the RPM of the supercharger is, it's all messed up. It's not where it's supposed to be. So the computer just thinks, well, it's got to be a mass airflow problem, throws this code. According to the test plan from Mini, as we saw, maybe you're replacing a computer. Maybe you think there's a problem with the supercharger. Now, the other thing I will mention with this, you might not necessarily notice anything's wrong unless you hear a noise in the front of the car, because if you've ever seen a Mini Cooper, next to the engine where that harmonic balancer is, and when that harmonic balancer fails, it really doesn't have anywhere to go because there's not a lot of room on the side of that engine. It's just kind of move over a little bit, maybe half inch or so, and then it's going to be bouncing off the side of the engine compartment, like the frame rail there. So it doesn't really have much place to go, and that's why it doesn't just go flying off the vehicle, right, when it fails. And apparently high failure rate on these. So let's go take a look at shop key information and see what we have in there as well. So we have our TSBs in there, and we have all of our testing and specs and all that we would need. I want to go down the parts and labor because I want to see if we went a different course and didn't come across this harmonic balancer problem. What might we end up be doing? So we go into parts and labor. First thing we see is the dampener, right? So that's the actual fix that we had on this. $400, about 2 hours of labor. Okay, not too bad. Computer. If we had to do a computer, an electronic control module, $1,500. And if we had to do a supercharger, it's $4,400 for new, $1,100 for reman, and it's about a 6-hour job to replace it. So when that fails, and you can find these pictures of these all over the place because apparently it's fairly common. But there's a picture of a failed one right there. So there's the outside ring, and you see it's just kind of attached with this this dampener rubber stuff in there. It's kind of like an injector mold or whatever, and it's attached in there. And then there's my pulley bolt would go. So you can see that's a pretty big failure there. So the that belt is not going to be turning as well as the crank is turning. So that's just a supercharger problem. Thought it was kind of appropriate for this particular class here. So that's superchargers. Let's move on to turbochargers. As I said, more common out there now. And it is an air compressor, and in this case, it is exhaust-driven instead of belt-driven. A few different types of turbochargers out there. So you'll see a single scroll, which is probably the most common one. Twin scroll, which is going to have 2 different size exhaust ports. So it will be able to spin up faster at a low speed. Variable geometry, which also takes care of that, not being able to spin up fast enough at low speed. And since it does use exhaust gases to drive it, could cause that turbo lag, which was what we're trying to get rid of with the twin scroll and the variable geometry turbo. Turbo lag is referring to at low engine speeds. I have low exhaust flow. So in that case, I have low turbo speed and I'm not compressing the air as much. So I don't get as much volume through that. So that could be an issue with that. But as I said, most manufacturers have gotten over that, gotten around it. And you can see we have 2 halves of this turbo. This side is the turbine side. So on this particular turbo, the exhaust gases come in the bottom. They flow through, they spin the turbine in here, and then they exit out the backside there. There is a center section in here. It is oil lubricated and coolant cooled. So it's got antifreeze going through there. And there's a bearing in there. And then on the other side, we have the compressor side. So air comes in through this way, gets spooled up through here, gets pushed in through the impeller. The case in here gets progressively smaller, so it comes out with a smaller outlet size, and then it is compressed on the way out. So that's how it works. And then here's kind of a blown up scale draw, or not really scale, but kind of a blown up drawing of what you would expect to see and how it works. So on a turbocharged gasoline engine, we have the airflow comes through the compressor side. As I said, it goes through the shell there and then goes through. Most cases, we have an intercooler as well. And we'll talk more about why an intercooler is important in a few minutes, but it goes through the intercooler and then it goes through the intake manifold, throttle plate, intake manifold into the engine, gets burned, which then gets created into exhaust flow, which then turns the turbine and then it starts all over again. So the turbine is used to spin up. And by the way, these things can spin at 100,000 RPM, tens of thousands to hundreds of thousands of RPM. These things are just screaming in there. So that can lead to some problems, which we'll see in a minute. But yeah, it really gets spooled up there, and then it just goes out the muffler. We also notice there's a wastegate that's used to limit the boost pressure. We'll talk more about that in a minute. boost controller, which is going to bleed the boost signal to control the wastegate. And then also the blow-off valve or recirc valve, depending on what it is, opens when the throttle plate closes. It allows it to recirculate or vent to the atmosphere. On a variable geometry turbo, on the exhaust side, what this does is it modifies the flow going through that exhaust impeller. So at a low rotation speed, we have a small amount of exhaust gas pushing on that because at a low RPM. It's going to narrow the nozzle, which allows that to spin faster. It's going to create faster airflow to spool up the turbo faster. When we have a high rotation speed, it opens up and allows a large amount of exhaust gas in there and to keep it spinning there as well. So it can control the spin of the turbo with that variable geometry. Now, how does it do that? It does it with an actuator. Now, some of them are vacuum actuated. Some of them can be electronically actuated, as we'll see in a bit as well. So in this case, this one looks like it's vacuum actuated, and it just kind of pushes this lever, which pushes a separate plate, which spins these vanes around inside the turbo. So this is very popular with diesels for sure, but there are other manufacturers that use it as well on gasoline engines. And then here's just a little GIF of that happening there. So you can see that outer ring gets actuated, gets moved, and then with some cams and such go in here and it moves those vanes and is able to change the geometry of the airflow going. Now, having said all that, what kind of problems can we have with the turbo? Usually, at least in my experience, usually the biggest problem you're going to find is mechanical failure. As I said, they're spinning at tens to hundreds of thousands of RPM. If I don't get oil to it fast enough, with enough pressure, with enough volume, dirty oil, that can cause a problem. Couldn't tell you how many times they came in on the hook and you just hear the rattling underneath the hood. It's like rattling under there. And what happens is, usually, since we have that center section there with the oil in there, if you don't get enough oil, if the oil's contaminated, if the oil's dirty, or if I have some sort of a way that the oil leaves the engine, had enough times where the dump hose coming out the bottom of the turbo actually melted. And all the oil went everywhere and it had no more oil in the engine and it fried the turbo. Most manufacturers use a case type bearing in there. Usually you'll only find the ball bearings in the aftermarket. I'm sure there's some manufacturers that do. But by and large, it's a case bearing, so it relies on that oil. If that oil's no good, you're going to have a problem. And then the shaft breaks. And then when the shaft breaks, the two sides run independently of each other and they're rattling around. And then, of course, it's not spinning, not boosting. And that's where we get this sort of look with all the fins all bent up. So that's a problem with a center shaft failure. And that's very common. The other failures I suppose you could see is maybe if it's an electrically actuated wastegate, could have a problem there. They'll probably set a code. Other than that, leaks, air leaks. If you have metered air leaving, that will cause a problem. Oftentimes in the boots and airflow out of the turbo, under pressure could, if you have an overboost situation, could blow a rubber hose or something like that off, and then you could have a drivability problem there. By and large, it seems to be mechanical would be the largest issue you run into there. All right, and then the wastegate. So in this case, we talked about the wastegate being actuated by either vacuum or it could be electronic. In this case, it's a vacuum operated one. We have this diaphragm in here. When the boost gets to a certain level, it bleeds into here, pushes on the diaphragm, which pushes on the rod, which opens the wastegate valve right here. So you can see how this rod comes through, pushes on it, it rotates out like a door, and then it just bleeds off the pressure there so it doesn't overboost. Electronically actuated wastegate, same type of idea, except for being vacuum operated. The computer sends a signal to it. So this one's off a Hyundai. We'll actually see this a little bit more in a little bit. But it works the same way. The turbo is the same. So we got the exhaust side here. We got the compressor side there. And then instead of having that diaphragm, we have a electric motor with like a cam on it, which pushes the shaft open and close, does the same thing. There's a closer look at that. You can see the eccentric shaft on there, where it's kind of like a cam. And it's just a stepper motor. DC stepper motor, open, close, all the time. We've got a little gear reduction in there too. Boost control. Oftentimes it can be mechanical. We just have a little screw on there that's a ball and a screw, or a ball and a spring, that keeps it from opening until a certain pressure. And then when it does, it opens the wastegate. Or in the case of this one's off like a Ford. It's operated by the ECM. Regulates the boost pressure, uses the vacuum and boost to open the wastegate so the solenoid can open and close. It's either in bypass or it sends it to the wastegate. Sometimes you can also see it called a wastegate control solenoid on it. Then we have a blow-off valve or recirc valve, depending on how the manufacturer decides it needs to be designed. So in this case, it's vacuum or boost operated in this case. What it does is when that throttle plate closes, I still have boosted air going in there. So when that throttle plate closes, like when I'm shifting or I lift off the accelerator, that's going to slam the door and all that boosted air slams in there, which causes a pressure surge, which then opens this and it allows it to bypass and recirculate back into the system. So we don't have it slamming back into the turbo, which is a bad thing too. So it's going to vent out. Some manufacturers do vent to the atmosphere. Definitely a lot of aftermarket units out there vent to the atmosphere. That's when you hear the souped up turbo car. They go down the road, and when they shift, it goes. Psh, that's the sound of this. That boosted air going up into the atmosphere instead of recirculating back. If you put one of those atmosphere venting blow-off valves on a vehicle that has a recirculating valve, you could have some sort of issue, fuel drivability type issues, because the mixture changes at that point. They usually don't like it, especially if you've had some other modifications. So usually you need some sort of a tune to take care of that. In order to take care of the metered air that's going out in the atmosphere. All right, and then the intercooler is the last thing we're going to talk about before we go live here. So as we would think about fluid dynamics, I guess if you want to think about it that way, but compressing air increases the temperature of that air. And we also know that cooler air is better because it's more dense. So we want to take that hot compressed air and turn it into cold compressed air. So we don't want to lose the pressure, but we want to cool it off. We want to take some of the heat out of it. So we use the intercooler to do that. So it's used to cool that compressed air charge. Most commonly, it's going to be air to air. So it'll be usually maybe like right in front of the vehicle somewhere where the airflow can get to it while it's driving. Could be air to water as well. Some manufacturers use a coolant through there. Or also I've seen some systems where it spritzes water on there as well. And that allows it to cool off too. I remember actually one of the ones I remember is the early Subaru STIs when they came over here. They actually had a water spray tank in the back and it would spray water on the intercooler to cool. There's a little button you could press on the dashboard to spray water on the intercooler. It's kind of interesting little gimmick, but hey, it worked, I guess. So a couple different ways of doing that, but overall, the moral of that story is that it's used to cool that compressed air. And we could have a leak there too. All right, so let's talk live on the tool here. Got a couple things I want to talk about. Take a sip of water. It's a little warm in here right now. All right, so first thing I want to talk about is let's go into guided component test. So if you have a tool with guided component tests, that'd be any of our tools with a scope, you have built-in training. Now, with this class, we have some training that applies to that. So if you have current software, it'll be classes on the top. Otherwise, it'll be training and classes down here on the bottom, but they've been in there for a very long time. If I go into classes and then I go into how-to, it is going to give me a whole bunch of classes. I got 65 different categories, but we go down here in a 15-minute forced induction system class. So this will give you a refresher. If you can't, if you don't need to refer back to this video, you can refer to it on the tool as well. So basic reasons for forced induction. And then we also have most common methods are mechanical supercharging, exhaust gas supercharging, which is what we talked about there. Different benefits in there as well. Exhaust gas turbocharger, so that'd be a turbocharger, and that's how it works. There's also talks about variable geometry turbochargers in there, and then different boost pressure schemes, atmospheric pressure, etc. And then we have positive displacement supercharger system, which would be the supercharger. So as we said, some engine power is required to drive it, can be excessively noisy, etc. Complex design. There's my twin screw. There's my roots type there we looked at earlier. There's a twin screw type, which has two different types of screws, does the same thing. And then I don't know. No, we don't have the scroll type. And then we have like a boost pressure sensor. Here's a waveform example for that. And so on and so forth. Bypass control motor. That is a pulse width modulated signal as well. So we can see that. A bunch of different things in there. Gets a little bit deeper than I have for a half an hour class. So definitely worth checking that out along with all the other classes. But that is under 15-minute forced induction system. All right, so let's take a look at a car. I'm going to go with a 2018 Hyundai Santa Fe Sport. It's a couple different things. First off, I'm going to go on the shop key and take a look at a couple things in here. 2.2 turbo ultimate. Let's do the ultimate one. All-wheel drive. Okay. So I found it interesting. I was looking through a bunch of different vehicles to try and figure out one that's good to show you. I found it interesting though that on this particular vehicle that I did choose at random, first two codes on that based on real world repair orders are turbocharger problems. So apparently we have some sort of an issue in the turbocharger system, not necessarily the turbocharger itself, but the two most common codes on a 2018 Hyundai Santa Fe with a 2-liter turbo based on 28,000 real-world repairs. 88 times it was this 2562, which is turbocharger boost control position sensor. And then this one is boost control position sensor circuit high. So out of those 141 times, those showed up. And then the rest of them were like misfire and chassis codes. So I thought that was really interesting that this first vehicle that it wasn't the first one I picked, but the vehicle that I ended up picking had these turbocharger codes in there. And if we click on it, it's going to do a search for it. And then we can take a look at the information. So here's the OE information here. Real fixes, top repairs, causes and fixes, specs, OEM testing, component operation, and wiring diagram. So let's go into testing first for this particular code. So this is the electronic wastegate actuator that we saw in the picture there. So there's the electronic wastegate actuator there. It's got a plug there, and then we have that rod that goes across to open the wastegate over there. It's kind of in the back, so it looks like it's not super easy to get to either, which, that's not very fun, but hey, it's there. So we get that electronic wastegate actuator there, and that's going to show us where it is. General description, let's see. ECU calculates the optimized fuel ratio by measuring the accurate air mass of the turbocharger. The boost pressure from intake manifold reaches target pressure value. ECU makes a part of exhaust gas bypass, so it opens the wastegate. Concentrated mixed gas makes much higher horsepower in explosion cycle. Let's see. ECU shows DTC when the wastegate sensor voltage at closed position is out of range. So it's a plausibility check. Battery voltage has to be higher than 10, less than 16, etc. Gives us our specifications down here for our supply voltage and current. Resistance specification as well, so we can test resistance. We can also look at boost pressure signals on the scope, the scanner if we wanted to do that. Some PIDs to monitor there. And then we check the codes. Here's how to check codes on the car. And wiring inspection, power circuit inspection. And then we want to make sure we got power, ground, and all that stuff. And then there is the wastegate actuator, just another view of that wastegate actuator. So how it can open and closes the wastegate right there, allows it to bypass. So we can see that there. And then here's how we check it. And then to verify the repair, you drive it, make sure the DTC doesn't. Easy enough. So let's go to wiring diagrams too and see what we got for wires there. So I'll pull up my engine performance circuit and electric wastegate actuator right there on the top. Pull that up, got to highlight that. And let's dim the other wires. So you can see what happens. So the motor is one thing. So it's a positive and negative electronic wastegate actuator DC motor. So that's just an open and close type thing. And then we also have a position sensor in there as well. So that's the sensor signal from the position sensor in the middle. So we got power and we got ground, and then we got the sensor signal comes back. So that should just be a 5-volt variable position sensor, kind of like the throttle position sensor. All right. So now we got some information on that. Now let's go into scanner. See what we can do. Actually, we'll go into guided component test first. Go into guided component test first. So you can see we've got a lot of things we can test on this Hyundai, and we'll go into engine because that's where the turbo stuff is. We have in here, as far as the turbocharger related things, we have the turbo recirculation valve. We have the wastegate valve. So the wastegate valve You can go in here, utilize an electronic wastegate actuator, as we know, consists of a DC motor which actuates a wastegate, two-step gear which increases torque, and a position sensor which detects status of the wastegate. ECU operates the wastegate actuator using pulse width modulation. When the wastegate is open, the exhaust gas bypasses the turbocharger turbo. So all the stuff we already talked about. And then we have the connector view here. So plus and minus on the motor, signal, ground, and 5 volts from the PCM. So there's just a 5 volt, like a throttle position sensor. I'm surprised we actually don't have a test. But, we can do a resistance test on it. And that is terminal 1 to terminal 3. So that is checking resistance to the motor. Should be 1.44 to 1.96 ohms at 68 degrees. So that's just one way to test it there. We can also go into the scanner, and we should have a functional test for that as well. So if we go into the scanner, close the vehicle, and that'll be under engine as well. And we have a functional test. We have system tests as well. So we'll go to functional test first, see what we got in there. Got a whole lot of things. So we got electronic wastegate valve, TCI bypass valve, which would also be related to that. So those are on turbo only. So we'll go into the wastegate valve. Key on, engine off. I'm going to do this while it's running. That would be bad. Probably won't even let you. And then we can watch the data stream as it goes. And then we can do start and then stop. So it's going to start moving and then stop moving. We can make it move. We can actuate that electronic wastegate valve and see if it moves. If we can get an eye on it, we actuate it while we're under the hood. We see it move. All good things. All right. And let's see if there's any system tests. I actually don't. We're going in here. So let's see. No, it looks like there's nothing related to the turbocharger in that. So we can sweep it back and forth, open and close it. See if the position sensor moves back and forth when we do it. So we could be probing that output side signal of that. And then as we actuate it, open and close, we can see how it goes open and close as well. And then we would expect a pulse width modulated signal if we were to test that as well. Not a ton of electronics on a turbo or a supercharger, really. It's going to be that wastegate solenoid. And then maybe a boost control solenoid are going to be the two things we're going to find out. Otherwise, it's mainly mechanical. So that's what we're looking for. Some sort of mechanical, maybe a drivability issue related to a leak, something of that nature. All right, so that's my time for this evening. Hopefully we have learned a few things about turbos and superchargers and all things boost related. So let's talk about what we're going to talk about next. Because next week's classes are all new again. So next week, it is getting warmer here in the northeast part of the United States, and I'm sure it's warm down south already. But what happens in the spring? We start thinking air conditioning. So we're talking about air conditioning. Now, we did have an HVAC class we did, a few months ago we did. So that was the inside of the car. We're going to be talking about under the hood stuff on air conditioning and a little bit inside the car, I guess, with the evaporator. But air conditioning, operating, and testing. We'll talk about the different R134, 1234YF, the different oils. Hybrid vehicles are different. So it's not your grandpa's air conditioning system anymore. So we'll talk our way through that next week. Same time, same place, 6 and 9 Eastern. If you want to join on Zoom, go to snapon.com/OT. You can join me there. Or the 6 p.m. Eastern goes to YouTube. So we're on YouTube right now. If you are watching on YouTube, please make sure you subscribe to the channel. Ring the bell, like the stream, all those good things. It does help us out in the long run. Get this out to more people is what we really want to do. We want to give you as much free diagnostic automotive training as we can possibly handle, as you can possibly. So if you go to YouTube and give us a subscribe and a like, that would be wonderful. Also, if you want to see any of our past courses, so this is number 40. This class is not our 40th class that we've done over the last year and a half. And it's everything from ADAS through data bus testing and the component testing we did over the summer, pressure transducers we did last year. There's my HVAC that we did at the end of the year last year as well. So a bunch of different classes that you can go through and check them out on the YouTube channel, youtube.com/Snap-on Diagnostic. There is a playlist for live training. All right, we'll get to questions in 1 second. I just also want to make sure we talk about Al's training as well. So my buddy Al also does scanner-specific training. So this is a really good intro if you're not familiar with using the tool or you want to refresh your course, or maybe you're not sure of all the capabilities the tool offers. Definitely worth your time. Monday, Wednesday, and Thursday. So Monday is Apollo, Wednesday is Zeus, Thursday is on Triton. Same time, 6 and 9 Eastern, 5 and 8 Central. You go to snapon.com/OT to hold your seat for that. Al just does it on Zoom, no YouTube, no Facebook. So you will need to register to check those out. Everything from let's make sure your Wi-Fi is working. Let's set that up. Let's set up your free Snap-on Cloud account. Let's walk through code to completion, a real world scenario on fast track intelligent diagnostics. And how does it help me as a technician diagnose a car faster and easier? So that's the first hour on all the classes, just on whatever tool he's teaching that night. Then on Wednesday and Thursday, since those tools have scope and meter functions, he goes through the scope and meter after about a 5-minute break in the middle. And that's about another hour. Zeus and Triton, scope, meter, guided component test, all the different functions, some real world examples that you would find there as well. So definitely think that's worth your time. Go check it out, snapon.com/OT for Al. All right, so we got a bunch going on YouTube. We got a bunch going on Zoom. So we'll look at that first. Let's see. All right, thanks for that comment there, Jesse. Always glad to help you guys out. A little bit of training. Let's see. All right, Jesse over at Hollingworth Enterprises. Definitely thank you for tuning in every week. I appreciate that. We've been commenting quite a bit on here, so definitely appreciate you tuning in. And we'll be doing this as long as you guys watch. We will be trying to do this as long as we can. Tom Spina, thanks for chiming in there as well. I know there's a few turbos in your world as well on the Chrysler side of things, so definitely enjoy that. Let's go over to YouTube. See what we got. Raymond, hello. Thanks for checking in, saying hi. Con Automotive, good afternoon from Saskatoon. So thanks for joining us there. Raymond also says, I left my dad's shop to work for Jeep Dodge dealership and using every lesson I learned from you. Thanks you. I'm glad I can help learn up on those different systems that you might not be familiar with. So definitely love that. GIE Auto, greetings. Thank you. Possibly not enough space in the van for a turbo. That could be. Not sure. I know. I'd love to see a twin turbo minivan would be kind of cool, I think. Shifting gears, welcome from Utah. Abel, thank you for joining us today. Auto Electrical Salas from Tijuana. Welcome from Tijuana, Mexico. Thank you. The Winton, hi. Thank you for joining us from the UK. And Brian Lamontagne, lots of great information. Definitely going to have to watch this one again. Absolutely. Watch it as many times as you want and tell your friends. That'd be wonderful. Bob on YouTube asks, is ShopStream Connect working? Not currently. So as you may know, we had some computer issues, I guess we'll say. And that's probably going to be one of the later things to come up, because we don't actually have a software update coming out until next week. So actually hopefully it's up by next week, because thinking about what time it is, this is the end of the quarter. So first of the quarter will be next Monday. So that means software comes out next month. So yeah, hopefully it'll be up by next Monday. Actually, I would think they're working towards that, come to think of it now. So yeah, no fear. Hopefully very, very soon, because they need to get it in place for the software update. So trying to get all the other stuff working, email and stuff, we want to get that working too. Plus Mitchell and Shopkey was the first thing to go. So we wanted to make sure that got up as well. So thank you for that question. Like I said, hopefully by the end of the week, latest or early next week, to get that up. So with that, looks like we got everybody covered. I'd like to thank everybody for taking a little bit of time out of your busy day to come spend a little bit of time with us. Hopefully we learned a little bit more about turbochargers, superchargers, and all things forced induction. With that, hopefully you can join us next week for air conditioning. Thank you again. Enjoy the rest of your week. We'll see you next week. Take care.